Hello everyone, I welcome you to my late night talk on Greach conference. It's all about Groovy and the shell. Not mussels and other sea fish, but your black screen on your desktop or your server. But why in bloody hell should I write shell scripts with Groovy? We have Bash, we have CSH, we have Perl. No? Yeah. Groovy's cool, isn't it? But besides from Groovy's cool, because I can. And if you want to get a bit more real with the arguments, if you want to do real complex stuff, for example, getting to a REST API, getting an XML file, parsing it, and doing your action based on that, it would be really hard to do that in Perl or other scripting language that you know on the shell. But as you know Groovy, it could be really easy. So this is one of the tasks. But as well, normal bash scripting testing is not so really easy. If you want to have unit tests and all the other testing stuffs, integrations, yes, you can, but sometimes not so nicely. With Groovy, just normal scripts, you can just test them as you're used to. And I have to admit, I know Groovy much more better than Bash or the other shell scripting languages. So if you're with me, so maybe I can help you a bit out to automate your stuff on your server. So just a bit of self-advertising. My name is officially Alexander Klein. Everyone knows me as Sasha. For anyone who does not know, Sasha is the Russian nickname for Alexander, and I'm named that for all of my life. So please call me Sasha. I don't react to Alexander. I work in Stuttgart with CodeCentric. CodeCentric again is a consulting company working for customers here and there. I'm in Java area and as well try to do as much Groovy as possible. I have been able to do this for the last 7 years in almost every project, so I'm yay. Aside from that, I'm Griffin committer and I'm really much into UI stuff and graphical design, not so much for the printer, but as well to help you anyone getting better UIs. But that's another topic for another talk, not today. So, for shell scripting, how do I execute Groovy scripts? I think anyone should know that. It's easy. Can you read that from behind? I hope so. Groovy test.groovy. It's what you could do, and I think everyone has done that. But it would be nice if we would just call the script that we would be used to using a normal shell script. We can do that using the shebang command. The shebang command, is, as you are used to from Bash and like the same as the hash number or the hash sign or the number sign followed by an exclamation mark and then a command that can do something like calling the user local bin Groovy. Groovy treats that as a normal command. So if you run that in your Groovy console or anywhere else, it's just a normal command, it's just ignoring it. But your Bash script wants to have that on the first line of the script. If that, the magic begins. Normally, you don't know always where your Groovy lies, because it could be installed in different locations. Besides that, on most Unix side systems, as well macOS, Linux, FreeBSD, we have the env. The env command is looking for a default registered command, user bin env, where is my Groovy command, and calling that. So this is working right out of the box, so you can as well provide your script to anyone who has a Linux or whatever system. All this stuff unfortunately does not work for Windows, but most of the other stuff we're talking about today is as well working for Windows shell scripts. But sometimes you have dependencies and you want to define a class path with that. And yes, you can do that very easily, if you just add commands, -cp and then a jar file, or what you would do in the command line if you call the Groovy executable. So this you can add there in the end in the shebang command as well. This is very helpful from time to time. You as well can use system variables. For example, $home. Then you can just reference to the home directory, there the lib directory, this is the directory where the jar files are, the jar files are located at. You as well have the ability to define, for the call of this script, define own system variables. There you can just say, before you call you say Groovy, you can just say var1 is value 1 and var2 is value 2, and that's what you want. You as well can change given variables this way very easily. But this does not work on Linux currently. It works on FreeBSD, it works on Mac OS X, but not on Linux. The problem is that this shebang command, this one, in Linux implementation just takes the whole string after the program that is called and gives that to the called command as one argument. So you get a string with spaces in between. But ENV would expect a string, would expect multiple arguments for calling, so we have a problem. But you can do that yourself. Yes, you have to do a bit of bash scripting there. This small script works just without defining own system variables. As I said, I'm not really a bash guru, I didn't manage that, but I think it is manageable. It's no big problem, I think, for someone who has a bit better bash knowledge than me. But just for information, if you just use that, I wouldn't use it for replacement, but maybe in your home directory in a bin, then you just reference home bin or something like that, you can use that. Then you as well can use variants, system variants, and you can use class path or other arguments. So take the slides, just copy it out if you need it. Another very useful stuff is Groovy serve, because Groovy needs a virtual machine. The virtual machine takes some time to start up. And this time is sometimes very tedious and something that you don't want to have in automating processes, especially on servers. Because of that, there's a very cool project called Groovy Serve that's running a background JVM, it's just doing faster startups because it's running a JVM in the background, and it's just delegating the script you just called to this JVM. So the JVM is already running. It's just told to get the script to execute. So this is about, I would say, 10 to 20 times faster. Depends on the script, and maybe you have a garbage collection or some other stuff, but it's really remarkably faster. So I would say have a look if you're doing that much more often than just for simple rarely tasks. So how to install? For Windows, you're in luck because Groovy Serve is part of the Windows installer. So it's already with your Groovy, the Groovy window installer. So it's part of your Windows installation, so you can just use it right out of the box. If you're on Linux, it isn't so hard, easy. Take JVM. JVM, install Groovy Serve, and you're done. Mac OS, you as well can use JVM, but additionally you can as well use Brew. And if you, for any case, don't have this possibility, for example, if you're behind an enterprise firewall and you can go to the internet or stuff like that, you as well can install it from binary packages directly. Set the path and you're gone. After that, you can call it the same like Groovy, you just call it Groovy client instead of Groovy. And you can state the same in your scripts with the shebang command. So this is all about starting. Now let's have a look about writing these scripts. The scripts we can do almost anything we can think about in Groovy. We just have to think about one restriction. I think it's a part of the Groovy template engine restriction. That is, if you reference a class that is not in the same script file you are currently in or you started, you want to reference that class. This class has to be in a file with the same name as the class file, so that it can find. So if all classes are in the same script file, no problem, you can do what you want. But if you have external classes you want to reference, just go the old-fashioned Java way and name the class name the same as the file name, or vice versa. After that, we know how to execute Groovy scripts from the shell. But what if you want to execute shell script from Groovy? Luckily, it's not so hard, because the string has a execute method. So we can just say make dir foo.execute, and it's doing exactly that. We as well have another version. This is a list of strings. It as well has an execute. Sometimes much more easier if you have arguments that have spaces in there. So for example, otherwise you have to add no, sorry, your main method. Don't know that words currently. Quotes, thanks. In the string version, you have to add quotes inside of your string. So you have to think about escaping and all these stuff. And there's sometimes much more easier doing it with the list as well. If you programmatically calculate your command you want to add, or just add arguments, stuff, this is much more easier sometimes with the list. So nice to know. So now you know how to execute, but on shell script you're used to that the shell script, the command is executed in the current command, in the current directory where you are currently, and you can just do cd for change directory to change the directory. This is not the case with Groovy. Here we have the nice thing that we can just specify the path where the command should be executed. Because of that, the execute command has two other parameters. One of them is the environment. We come to that later. So the system environment, so variables, and the file for the home directory, or for the working directory for the executed command. So just add a file and you're good. If you want to set some environment variables, it's a bit more tedious, because you have a list, not an array as you would expect. A list where you have to add the assignment as it is in the native format. Mostly var equals test. There you can have multiple ones as a list, and then this executed command has in its environment, executed environment has these two variables, and only these two environments. So if you define something here, this is what they get. So it's not inherited by default. So if you want to inherit what the current environment is, you have to do it this way, or I do it this way. It's simplest for me. It's just I use these asterisk map format for, I don't know if you know that, if you have the literal for a map and the key is an asterisk, and after that you have a map, then it copies all the key value pairs from this map into the map that is created by the literal. And after that I just set my variables, and I as well can override variables over that. So now I have a map then I collect over this map where it just creates strings with key equals value, and I'm ready to go, have my list to run it. Sometimes I want to work with the result of an executed command. For example, here I do ls, want the file system output. Luckily, I have the getText method that I can use as the getText property, and this command is just waiting until the process has executed and giving me back the result as a string, so I can work with it. This is very, very handy. And after that, as a string, I can do anything what I want to do with the string. On Windows, sometimes it is very helpful and important, because this not always works, that you just do that with a cmd/c in front of the command, because many of these commands are just shell commands and not the command and not really executables, like mostly in Linux, but there we have the same problem as well sometimes. If you want to, if you think you have a long output and you don't want to wait until everything is processed, you as well can do it streamingly. You can just say, okay, execute, give me, it's creating a process object. This process object has an input stream. Then you get an input stream, you can do things like each line or whatever you want to do. So then you get for each line, you can do any action, like printing or whatever. And a shortcut, instead of .input stream in Groovy, you can use .in. If you have input stream, you as well have error stream and output stream. Shortcut for error stream is .err, and I think for output stream is .out. The thing what you have to think about is the input stream is the way where you get the output from the command, and the output stream is the input to the command. Technically it's logic, but from user's point of view it's a bit strange. But yes, it's right if you say input stream is giving my Groovy command and my Groovy script data as input. So this is the output of the executed command, and the other way vice versa. So if you have more complex needs to start that, you as well can use the process builder as a Java class, and add redirect error stream true. This means that normally you just get the error stream and the output stream of the executed command as two streams. But what you're used to on the shell is that these are mixed, just intermingled. You get both, get an error and the output stream in the same stream. And if you want to have that behavior, you have to use this by the process builder .redirect error stream. Then you get a stream that has both of that. After that, you start the process to execute it. Then you get the process while it's running, and you can say, okay, get me the input stream, and the input stream now as well contains the error stream, and the error stream will get a null, I think. And then you can work on this stream now. If you want to have a bit more control over the process you call, for example, make dir is a fast command. I should have taken something different. But if it's a long running command, you want your Groovy script to wait until it's finished. So if you do the execute, it just runs and then continues with your string asynchronously. Therefore, the process that is returned by the execute method has a wait for method. But the second thing that we want to have is that we want to have an exit value, if it worked or it didn't work, or if you have any other things. We have the process as well has an exit value method, so you can get this exit value and you can have your normal scripting. you as well can do it in one thing, because the wait for is as well returning the exit value. So you can just do command.execute.wait for, and the result is the exit value. So you can all put that in the if command. But sometimes, I'll wait for the command, and if the command is just doing stuff and stuff and stuff, you might have a problem. Because of that, Groovy added the nicely command of wait for or kill, and you can add an amount of milliseconds after that the command or the process will be killed. I would advise to use it in 101%. Maybe there are some use cases where you don't want to, where you want to wait forever, but I think they are very rarely. So just use wait for or kill. And in this case, for example, if you say, okay, let it run, I do other stuff and I don't want to wait, but maybe I have some detections on the file system, so this is one of the tasks where I just don't want to wait for, but it will take some time, and then I will check if it's still running, and if it should not run because there's some problem or something and want to kill it, I can do that with process.destroy, just destroying this command. So if you want to do it manually. So handling the output. Handling the output in this case is you have a process, my commands doing something, execute it. I as well can take these streams, for example, or put it into string buffers as well as streams and readers and writers, I think. For example, there, okay, I take here, I say make 2 string buffers and call the wait for process output. The real problem is there are commands that are waiting, and the situation that this could create a deadlock, because the process the command is writing stuff into the stream in a buffer for output, and especially in Windows, this buffer is limited. So, and if nothing anymore is going into this buffer because nothing is reading, it's consuming it, then you get a deadlock, so the other command is waiting until it can write some other stuff. So, in this case, it's easier to say, okay, just wait for the process output, and then you get all the output in these string buffers, and you can work with it as you want to. If you don't mind about this output, as a shortcut, you as well can use the consume process output. It's doing almost the same, but throwing away the output. So, especially in these cases where you have long running tasks on Windows, sometimes other situations on other systems as well, just think about you have this consume process output to just throw away the output and continue with that. But this does not mean that it is blocking. So, therefore, after that, you have to call for the wait for or wait for and kill. On shell scripting, you as well are used to piping commands. You can do the same with Groovy scripting, shell scripting, in 2 ways. One of these ways is using the pipe to method. So I have the command, less of a stuff, execute it and pipe it now to a grep. And grab it, and then, so because there I say, okay, I execute this command and then pipe it to this command that I execute, and then I wait for the result. And the result is the result of the last command, so in this case the grep. So I get the stuff, what I need. The other way is using the OR operator. That is, I think it's really an alias for the pipe to method, but working with it is a bit different. The simplest way is just take the 2 processes for less and for grep, and then pipe them there, and then wait for the text with the OR operator. As well on the shell scripting, normal shell scripting, you're used to use wildcards, asterisks and question marks. The problem is this is shell functionality. This is something that the bash or C shell or whatever shell you're using is providing to the user. It's nothing that's on the system level. So because of that, ls**java will not work. But you can use, for example, the sh-c. So this is calling a shell with the command that is after the -c argument. So this means call a shell and execute this command. So just think about this. If we want to use asterisks and wildcards and stuff like that, think about that as a shell feature. Use the shell. So execute it. Because there's so many things that you have to think about when executing, I love to have some helpers. And there are some multiple ways you can do that. As well, thought about creating a Groovy extension method or a custom base script for my script, or stuff like that. So totally open. You can do all the stuff you would like to, as you would used to with Groovy. This is just a normal helper. This class is called shell. The first thing is I just get me the current system environment and my current directory as current home directory. I said, okay, normally you want to have this redirect error string is what you are used to, so just this default is 2. And I say 5 seconds should be enough for a normal default executed shell script, shell command. So now constructor, have it where I can give the environment variables that I want to add or use. In this case, I say I want to add it to my default system environment. And whatever this return is just the leftover from testing. Just get rid of it, sorry. So then I just have some helper methods. Oh no, sorry, it's not the constructor. Please remove my command. It's the env. There I have this method for setting variables, and I can use that multiple times. So for easier, like a bit of a DSL. Setting maps. I can add a map, but as well, if you know, you as well can get rid of these brackets. So just use it as named parameters. Would be nicer to write. Then the way to set my directory, setter, dir directory, where I can set a file, or I can set the string, what I'm used to very often, that's just doing the file for that. I always return this, then I can use the normal Java builder pattern for like that. Then if you want to override the redirect error stream from true to false, you can do that, and as well the timeout. This is simple, normal stuff. Then the execute. This is where the real work is done. In this execute, I just give my command when I want to execute and say, okay, now I'm using this process builder. And I always execute it via the shell, because everything that you execute on your command line is executed by the shell, so it's no problem to execute everything in the shell. So here, okay, shell -c, and this is my command. This is my directory where it should work on. There, please set my redirect error string setting. Then my environments. There I do this collecting from this map to this string, so I don't have to hassle with this format. And then start this process. So this just gives me the process, and then I have the call method. The call method is explicitly executing it. So there I can say, okay, I'm using this execute command method here. So I just give my command and I say, should I consume the output or not? By default I say, yes, please consume it, because normally I don't need it. Okay, then get me the process, and if consume, then consume it, otherwise don't. And then wait for or kill with my timeout, or if I set my timeout to 0, then just do a wait for if I want to do that. So just and then return the exit value, just for a little helper to have it handy. And for the way where you want to handle the output stream or the result from that, just do the have the each line method is just getting the command, getting the input stream, and do in each line my closure that I give there. So with this, I can write it fairly nice, I think, doing just the shell, implementing a new instance, then say call this command, so I want to, or I say this shell in this directory, please call this command, or here execute for each line of the ls command, print it, and here for each line print that. The nice thing here is that it is almost the same than you would write shell scripting. I think if you would think about it, you as well could could form it a bit more DSL-ish, so you could have it a bit more like shell format, what you are used to from a normal shell. But you don't have to. From that on, you can use all the other stuff that you're used to with Groovy. There's some helpful tricks from time to time when writing shell scripts. One thing is accessing system variables from inside of your script. It's very easy. The system has this getEnv method, and there you can just add the pvd or .home or whatever and just work with it. If you want to access system properties, you would do that almost with, like in Java, system.properties, and then get the user.dir, but user.dir has a dot in it, so please put it in quotes, double or single quotes. Another thing that you often want to have is getting your PID, the process ID of the executed command. Therefore, it's a one-liner, but it's not trivial, I would say. It's not so intuitive. But you have the management factory that gives you an mx bean, the runtime mx bean. There, get the name, then split it with the @ sign, just name the part that is in front of the @ sign, and convert it to an integer. This works on Linux, FreeBSD, all the stuff, but not on Windows. But I don't think that you have PIDs, process IDs in Windows outside of PowerShell. I'm currently not aware of how to use it with PowerShell. Another helpful thing is the command line CLI, the command line interface builder. Maybe you know the Apache Common CLI. It's an Apache project for easy parsing of command lines, and Groovy has a own builder for that to simplify that a bit more. So we have a DSL on top of that. Just an example how to use it. I have my script with a shebang, just a new instance of the command line CLI builder. There I can just add what is the usage, what is the command that's written as usage. So if I have a help screen, always have this usage, colon, and then something. Here it's my script. I can add there what I want to as text. And then I say, okay, command line builder, then have the with closure, so I don't always have to do CLI dot something, CLI dot something. So then for all of my small versions of commands, so normally I have a minus v and a minus version, for example, this case. So I just create methods. It's dynamic, so it doesn't work with compile static. Minus v, so I have the v method. This method has a long option. There I have the version. This is the minus version for the same command. And as well can give a description. This is a description that will be shown in the help text for this command. In this case, we just have one argument, so it's very trivial. We'll see a bit better later on, a bit bigger later on. Then what I have to do is just take the command line argument and parse the args. The args is automatically injected into a Groovy script. These are the arguments that the Groovy script is called with. So then, if the options that had parts are not valid, so null, or if there are none in there, then execute, then something's gone wrong. If there's something gone wrong, the CLI automatically shows the error screen that includes the help screen. So it gives an error message and then the help, as you're used to in shell scripting. So, and if not, if I have something, I just look in my options, do I have the V? The V as I defined it here, up here. So if I have a V, then do something with it. In this case, print the version number. So this is very trivial, a bit more complex sample. This is what we want to have. If I have a script, do script minus help in this case, I have the my script, options, args. Then I have the question mark and the help as a long version. Question mark that is used in Windows environment. Then I have the special case of only a long version. So only minus config, but I don't have a short one. Then I want to have a minus d as you're used to from Java, where I have property equals value. And this as well could be added multiple times as you're used to with Java minus d commands as well, arguments as well. Then I have a minus s and a minus source and a minus source. So the minus source is a short version with a long name, it's just not the long short term. But all these three have the same ability, or the same format, or the same logic behind that, and I have this classical minus v inversion. So how to do that? Okay, creating my CLI builder. There, my usage is a bit longer. I add the options and args. It's just the text that's shown. Can do what I want to. Then have my closure with the CLI with. First off, I have these source. This is the minus source version. I have no long option, but I have an argument. You can specify how many arguments you have. In this case, you can have one argument. And the name of this argument that is shown in the help file is path. And, oh, this is not readable, it's false there. It's very yellow and gray. It is not an optional argument, so it is needed that you have this argument. And then the description for that. So this is the normal case, one of the normal cases where you just have a short version. The other thing is, is this correctly? Just step over this, just have the other way around, the normal version where you have a short version, the S, and have a minus source for the long version. There you have this long opt, and then you have this as well has one argument, it's as well path, and it's not optional, and my command. So these two, I think, are the ones you have most of the time. Then we have this special case where we don't have a short version, but only a long version. So if I said the method name that you call there is the name of the short version, and as we don't have a short version, you just use the underscore. The underscore is the special method name for no short version, but then you have to add the long option, of course, otherwise it doesn't make any sense. So long option config, one argument, it's called arg, it's not optional, description, that's it. Then we have the case of the question mark. The question mark normally doesn't work in Bash on Linux suite systems, but it's the default on Windows. But the question mark is not a valid name for a method. So you cannot use question mark and then the brackets. But you have to put the question mark in quotes, then it works. As normally method names as well with space and all this stuff is no problem in Groovy. If you put if you put it in quotes. Then we have the same with the version. V, version, that's it, no arguments. And now this minus d. This minus d, now we say this takes two arguments, the key and the value, the property and the value. And we say, okay, if we have two, then we have to define how it gets multiples of these one argument. So we add a value separator. In this case, it's the equal sign. So it will be split by the equal sign automatically. This is the name that is shown in the help. And go for it. So how to use that? We just now defined how it should parse. No? Now we can parse it. And we say, okay, as well our exit if we have any problems, if some error is there in the parsing. Otherwise, first of all, take the question mark. If the question mark is okay, if this is there, then do the usage. Question mark has no long version, so fine. Next version is the V. The V has no arguments, but has a long version. And the short version for testing here includes the long version. So if someone specifies the minus version, this is the same, that this works as well here. So, and now we say, okay, in this case we have some other options. We want to do something different. It's how you structure it's your logic. But now the config is the one where we don't have a short version. And if we don't have a short version, then the key in these options is just the long version. So you just use the opt.config. And now this special thing with these minus d, there we have arguments. Oh, just skip that before, it's easier to do that down there. Here we say with the minus s and the minus source and the minus source. So because minus s and minus source is the same, because minus source is the long version of minus s. And this minus source is the third one, I just added with an or. Okay, and if that is that, I just set my home directory or override it, otherwise I just take the user directory. And I'll have to look at it for take the string that is defined for that. So great, works with that. The interesting thing here is you just check here for the opt as, and here you can use it. This means the result that you get and that you can check on in Groovy is really what he defined, what the user defined for. So, and if you look to these minus d that could be there multiple times, and with multiple arguments, how do we handle that? It's not so difficult, because there we have the special key that's called ds with the s behind the short version. That gives you a list, and this list contains all these is a list where you have, for example, if you have, I think I have an example there. No, I forgot it. I have minus d a equals b and minus db equals c. Then you get a list with a, b, c, d. So I know I have two arguments there, so just collate it, so split it in multiple lists with two arguments, two elements. Then I make a collect there, so I add this at the join these two, so I have key value because I know the first one is the key, the second one is the value. Get a list of these strings, join that with a page break, and just print it out. So this is my logic. But the important thing is that I get a list with all these arguments that are specified in the list in this way. Okay? Running out of time, doesn't matter. Right after that, and do that. So just skipping over that, but I just want to notice you for if you have some dependency management, have a look to Grape. Grape is the dependency management built into Groovy, and you can just use it with annotations like that, especially for as well as imports. You can just say, okay, grep group import. Then it's automatically downloading that and using that. So as well, you can use all the libraries you normally do in your project as well, right from the script. So and then, because of the time, I think I'll skip over that a bit. You can have a look at that in the slides if you want to. Yes, and just one thing, you always forget, if you're in an enterprise environment, you need proxy. There you have reference how to do that. So beside that, I hope I could give you something useful for your daily work or for whatever you want to do. And I thank you very much. And are there any questions? No?
Are you going to post the slides?
Sorry?
Are you going to post?
Yes, I will post it at SlideShare. My user is Sasha_Klein. And they will find it, I think, in the next day. So then, any other questions? No, then I had been asked to send you right to the track 2 room because there will the conference closing take place. So thank you very much. Have a good travel home. Bye.